Hello everyone, welcome to this channel StatisticaHub. So today we are going to solve few more problems from the IITJAM 2023. So let's have a look on the problem number problem number 11. Okay, so like this problem is for like 2 marks. Okay, that meant to say they will be taking some time. Like technically we solved problem number 1 to 10 and they were like straightforward. We didn't require too much attention or too much calculation in those parts, but in these calculations, like in these particular problems, like from 11 to 20, they are having a weightage of roughly 40 marks. So we need to have put on some effort so that we are able to solve these problems. So let's have a look on the problem number 11. So if I go to the 11 number problem, then it says that we are having some random variable x such that the MGF of x exists in the neighborhood of 0. Fine. So like first thing that you have to measure is like the MGF of x exists in the neighborhood of 0. Okay, so there might be something that is having a linkage to this particular thing. Okay, then on the downside you can find the expectation of x raised to the power n, that is given to be like minus 1 raised to the power n 2 by 5 plus 2 raised to the power n plus 1 by 5 plus 1 by 5. Okay, and n can go from like 1 to 3 and so on, and we need to find this particular probability. So like so far as I can observe in this situation, that okay, we are given some expectation, like general expectation, like expectation of e raised to the power expectation of x raised to the power n. Okay, and I can see few pattern in this situation, that okay, we are having some sort of pattern. So I will make use of this thing, and like the statement, the random variable is having an MGF that exists in the neighborhood of 0. That means to say the MGF will be in some format of some power series expansion. Okay, power series expansion of what thing, and it will be having some terms of expectation of x raised to the power n. Here n can go from like 1 to and so on, that is given to us. Okay, that's the first observation that I can see, and I can see I'm going to make the use of this thing. Okay, then we have to go for a few things, that okay, I have to calculate this probability. Then I can write this to be like probability of x minus 1 by 2 greater than 1 plus probability of x minus 1 by 2 less than 1, less than minus 1, sorry. Okay, so that is the first thing that I can see. So if I go on solving this thing, so that will be probability x greater than 3 by 2, and from here I can see probability of x less than minus 1 by 2. So finally I have to find this thing. So mark is say equation 1. Okay, then I have to make use of MGF, so that need to so we have to write the MGF, of course. Okay, so if I go for the basic thing, that okay, if you remember like what is the expansion of e raised to the power x. So if I say e raised to the power x, so that is nothing, that is basically summation of r going from 0 to infinity. Okay, x raised to the power r divided by r factorial. That's the expansion for e raised to the power x. So you have to remember these kind of expansions because they are being used many times. Okay, either in the exam or in the real world when we go for solving some problems in your masters maybe. Okay, so we have this situation. That's all that we know. Okay, so if I start writing the MGF, then I know I have to write the MGF. So what is the MGF? Like mxt, that is nothing, that is basically expectation of e raised to the power tx. That's the thing that I know. So I can just apply the expectation of x to this thing. Sorry, the e raised to the power x expansion is like this thing, so I can make an expansion of this thing. So that is nothing. So if I go on writing this thing, so that will be expectation of if I go on expansion, so that will be summation, like r going from maybe 0 to infinity. Okay, t raised to the power x raised to the power r over the r factorial. That's the thing that I know. Okay, then if I can see like t raised to the power and r factorial, there are something there. Sorry, t raised to the power, that is something. Okay, let's take this expectation on the inside format, that okay, if I go for summation r going from 0 to infinity, and I can write this to be like expectation of tx raised to the power r divided by r factorial. That's the thing that I can write. Okay, fine, like there is no error in this situation right now. So if I go on writing this thing, then I can see this t and r factorial, I can take them out and I can just write x raised to the power r, so that I can make the use of expectation of x raised to the power r. So I can write this thing in this format, that okay, that will be summation r going from 0 to infinity, and we are having t raised to the power r over r factorial, expectation of x raised to the power r, and this is the thing that is given to us. So if I plug in the value of this thing, so that will be coming out to be summation r going from 0 to infinity. Okay, and we are having t raised to the power r over r factorial. And what is expectation? So that is given to be -1 raised to the power r 2 by 5, fine. And the second term 2 raised to the power n plus 1 by 5 plus 1. That's the 1 by 5 that is given to us. Okay, so now if I multiply the terms on the inside, then I can get something like summation r going from 0 to infinity, and we are having 2 over 5, and I can write this to be -1 into t, okay, raised to the power r over r factorial. I think that is correct. Okay, then if I go for the second term, so that will be nothing, that will be summation of this summation of r is from 0 to infinity t, and we are having, so that will be r basically. So I can see there is some power that is common, so I can write 2 by 5 into t raised to the power and 2t raised to the power r over r factorial. Okay, and on the final scene I can go for summation r running from 0 to infinity 1 by 5, and what we have t raised to the power r over r factorial. So I can see this summation on this summation, like if I take out the coefficient, then this summation, that term is something again the power expansion, or can say the power of something like e raised to the power something. So I can see that this thing is nothing, the mgf that I'm getting, that is coming out to be 2 by 5 e raised to the power, what is this thing? So that will be minus t, and the second term 2 by 5 e raised to the power 2t, okay, and the final, that is 1 by 5 e raised to the power t, yeah, e raised to the power t. So you remember the basic formula, like when we have discrete case, then we can write the expectation in this form. So I can see my random variable x, this will be taking only three values, -1, 2, and 1, and the respective probabilities are 2 by 5, like these are my probability function. Okay, so that are coming out to be 2 by 5, and this is coming out to be 2 by 5, and you have the final term, that is 1 by 5. Now I have to plug in these values in this equation, like probability that x is greater than 3 by 2, so that is 1.5. So x is greater than 1.5, that means to say x is greater than, or greater than, no, x is equal to 2, basically this probability. So that is coming out to be 2 by 5, and the other term that we need is negative term, that is some negative term, I guess, yeah, that is less than -1 by 2. So we have something, this again 2 by 5, so 2 by 5, so that will be coming out to be 4 by 5. So I think that will be the answer. Is there any option? Yeah, so option A is correct. Okay, so there is a possibility that I have done some kind of calculation error. So if you find any, just try to solve it and just drop me a message in the comment. Okay, let's have a look on the next problem. Okay, so like I can see like this is some function that is well known to us. Okay, this is very well known function. Like if you remember something, like before going to the problem, I can see that this is a random variable that is taking some values from 0 to infinity. Okay, and I can see the probability function, or can say the recursive relation, that is given to be probability of x plus 1 that equal to sum ln3 divided by x plus 1 into probability of x. So basically, if you remember the recursive relation for the Poisson distribution, then that look like probability of x plus 1, that is nothing, that is lambda over x plus 1 probability of x. So I can see like this is basically some x random variable that is following some Poisson with lambda, and I can just see that lambda is nothing, that is ln3. Okay, so if I know this thing, then I can go for, okay, they only wanted the variance of x. So variance of x will be nothing, that will be lambda. So that will be option D. So that was state problem. No need of any kind of calculation, very direct and state problem. So let's have a look on the next problem. So if I go to problem number 13, okay, so this is some problem that I can see. So we are given some two observations. Okay, we are ID random variables from the common probability density function, fine, and x. So what is this function? I can see the CDF, sorry, the PDF. The PDF is basically for exponential 1. That's the thing that I know. Okay, then it says x1 is basically the minimum, x2 is the maximum. Okay, we are having only two observations, and one is the minimum value and the other one may be maximum. Then which of the following statement is false? Okay, so we are given few statements. If I see, there might be some probability. Okay, so we have this situation. So we have to solve these four options. So rather than going for solving all the problems, if I go for the final solution, then in spite of going for the final solution, let's have a look on the final one, like the D option. So the D option says expectation of x1, that is basically 1 by 2. So let's have a look on this thing. Is that correct? So if I go to finding the PDF of this x1, so PDF of x1, so if you remember some concepts from the order stats, then the PDF of x1 will be coming out to be n times of 1 minus CDF of x raised to the power n minus 1 fx. Okay, I know all the things, so n is basically 2 in this case, and 1 minus what is CDF, so that will be nothing, 1 minus, I remember as follows, e raised to the power minus x, I think so. Okay, and we have PDF, that is e raised to the power minus lambda, so again e raised to the power minus x. So if I go on solving this thing, then I can see that is coming out to be minus minus plus plus and so on, e raised to the power minus 2x. So basically this x1, that is following some exponential with a parameter 2. So that means to say expectation will be coming out to be 1 by 2. So is the, so that is correct. So I can say this is correct, this is not the incorrect one. Okay, so if I go to this thing, so before this thing I have to solve this thing also, because technically that is a combination of few things, and I think I cut out something, maybe I cut out something while cropping the pictures. No, that is fine. Okay. Okay, so I can see if I have to calculate the first option, that okay, if I go for like, you have to remember one result maybe. If we have exponential case, then we have something like, if we have to calculate, this is order stats, and if I just subtract the other one, this xr from this thing, then that will be exponential with parameter n minus r into theta. So in this case, n equal to 2 and my r is 1 and r plus 1 will be 2. So technically that is thing is coming out to be x2 minus x1. That is nothing. That is an exponential. That is 2 minus r. R is basically my 1. So 1 theta. So that's the thing that I can see. And theta is basically 1 in this case. Okay. So this is the case, like we are getting some exponential. And basically that is nothing. That is gamma 1 comma 1 by 2. Or if I multiply that by 2, then maybe we are getting this case. Okay, because this initial case like for this case, that will be nothing, that will be gamma, I feel so 1 comma 1. Okay, that is for x2 minus x1. The distribution for this thing will be gamma 1 comma 1, because that is basically this one. And if I multiply this thing by 2, then that will be converting to gamma 1 comma 1 by 2. Okay, and you remember like there is some relation between chi and gamma, so I can see this thing will be basically chi square with 2 degree of freedom. Okay, so easy. So I can see the option 1, that is also correct. Now we have option B and C, only 2 are left, so we have to look on them also. So let's have a look on these. So like if you remember what is F distribution. Okay, so how do we just construct the F distribution? So assume that you are having some X and you are having some Y. Okay, this is about the construction of F distribution. So if this is having some chi distribution with say v1 degree of freedom, and this is having some chi distribution with say v2 degree of freedom, then if I just make the ratio of them like x divided by v1 divided by y divided by v2, that is basically my F distribution with parameter v1 comma v2. So I have to check it out, like is this or this, they are having the F distribution or not. Okay, so either you just go for calculating the distribution for these one, and apart from that I can see one more thing, and if I go to the option C, then I can see a few things that if I go to the option C, then it says that we are having probability that 3x1 less than x2, that is having 1 by 3, I guess, that is given to us. So if I see on this situation, then you can see this particular event, this can happen in two ways, and they are both equally likely. Either 3x1 less than x2 or 3x2 less than x1. These are like equal probable chances. Like both of them have equal probability. They are equally likely events. Okay. And in this case, my x1 may be x1. And in this case, my x1 may be x2. So I can see both the events are equally likely. So I can see the proper total probability for this case, that will be nothing. That will be 1 by 2, such that probability of this 3x1 less than x2 plus 1 by 2, because both the events are equally likely. Okay, and we have probability that 3x2 less than x1. Okay, and we know the distribution of these things. So basically you can just write it down to be that thing is coming out to you. If I go solving these cases, then if I go for solving this case first, okay, technically both the events they are roughly same because they are identical, IID. So if I just solve this thing, then I can just make this to be 2 times. So basically this particular event that will give me this probability. Okay, so if I go on solving this thing, so that will be coming out to be integration, and we are having x2 that is greater than 3x1. So 3x1 x2 to infinity, and the lower bound for x1 that will be coming out to be like from 0 to infinity. Okay, and I can write lambda e raised to the power minus lambda. So e raised to the power minus x1 e raised to the power minus x2 dx. So if I go on integration of this thing, then that will be e raised to the like from 0 to infinity e raised to the power minus x1, and that will be e raised to the power minus x2 with some limits, say 3x1 and infinity. Okay, I just made the negative sign with interchange with these limits. Okay, and we have dx1. Okay, this is some dx2 dx1. Okay, so that is coming out to be integration from 0 to infinity e raised to the power minus x1 e raised to the power minus 3x1. Okay, dx1, there is 3. So technically we are left with integration from, did I write something wrong? So that will be e raised to the power from 0 to infinity e raised to the power, what is this thing, minus 4x1 dx. That is the thing that I can see I'm getting. Okay, so if I go on solving this thing, so that thing will be coming out to be e raised to the power, what I'm getting, e raised to the power minus, what is this integration, why I'm stuck in this case. Okay, e raised to the power minus 4x divided by minus 4, basically that is the integration. Okay, so that is coming out in this case. So I can see if I put on the limit, so the limit like from 0 to infinity, so that will be coming out to be like e raised to the power 1 by 4 e raised to the power 4x. Basically the limits are like from infinity to 0. So if you plug in the value of 0, so that will be coming out to be 1 by 4. If you plug in infinity, that is coming out to be 0. So that is like 1 by 4 will be the answer. So that means to say the option C, that is incorrect. Okay, so we have option C, that is like correct answer for this particular problem. That is false statement. So you can just check it out and you can solve the other options and have a recap on the basic concepts. Okay, and then if I go to the next problem, the problem number 14. So like this will be the last problem for today's session. Okay, I will add on the few more problems in the upcoming classes or in the upcoming lectures. Okay, so like okay, this is the problem that I can see. I have solved many problems like this using large sample theory. Okay, basically large sample theory is like a beautiful chapter and very close to my heart. So I can feel like we can solve many more problems without going into the deep inference part if you know the basic concepts about the inferential statistics. Okay, then it says that you are having some normal distribution, that okay, normal distribution is given to us. We are having x1, x2, x3 and x4. Okay, and you are taken up 4 observation. Okay, and both the theta and sigma, they are unknown. Suppose that x bar, that is coming out to be 1 by 4 summation I going from 1 to 4 x I equal to 3.6. Okay, so basically we are given some x population that is having normal theta comma sigma square, and both are unknown. Okay, and it says I'm having sample n equal to 4, sample size is 4, and we are having x bar equal to 3.6, and we are having s square that is given to be 20.25. Okay, so you have to test something like this. Okay, the h naught is given to be theta equal to 0, h1 is given to be theta not equal to 0. That is a two-tailed case. Okay, so I will just go for the basic concepts on inference that everyone knows. Okay, so we have to apply the likelihood ratio test or anything, so I usually ignore this thing. Okay, so that's my approach. I usually don't go for the likelihood ratio test because technically that is requiring much more. But if we know the basic concept from the large sample theory, we can solve the problem without using it. Okay, so in this case, you can see like the sample observations are given and the sample observations are having a sample size 4 only. So that means to say we can't apply the normal distribution. The sample size is not large enough for applying the CLT in this case. And along with that, we have an assumption that, okay, we are taking up these samples from the normal population. So technically, if the sample size is small and the sigma is not given and the parent population is roughly normal, then you can apply the t distribution. So that means to say my test statistic will be some t statistic with degree of freedom that will be having 1 degree less than the sample size. So degree will be 3. For the test statistic, that will be coming out to be x bar minus theta divided by s over root n. Okay, so if I go for this calculation, then that will be coming out to be 3.6 minus 0 divided by under root 20.25 divided by 4. Okay, so if I go on solving this thing, then I am getting something 20.25 divided by 4. Okay, under root answer 2.25 36 2.25. Okay, so I'm getting something like 1.6. So basically you have to calculate one probability, like they are talking about the p-value. So you just go for like this is a two-tailed case, so that means to say this is having this kind of situation, that okay, you might be getting some t that is 1.6, you might be getting minus 1.6. So you have to calculate this probability and this probability. So we know the degree of freedom, we know the t value, so I can just calculate the t with degree of freedom 3 and that p score that is given to be 1.6. So I will see probability 2 times multiplied t greater than 1.6 for a case of 3 degree of freedom. So if I calculate that part, then that will be coming out to me. For that, I need to use my phone. Okay. So we are given a t-score that is 1.6. So if I just go for this situation, the t-score is 1.6. Degree of freedom will be 3. And we are having two-tailed case. So basically the probability that will be coming out to be, okay, so I can see the probability is coming out to be 0.208. So the option B will be correct. Okay, so again, this was again like very basic program. If you just go for the basic knowledge that we have for the inference course. Okay, so this was discussion on problem number 11 to 14. I hope you enjoyed the video and like the solutions. And in case you find any difficulty or any error in the solutions, let me know in the comments. Okay, thanks. Have a good day.